All right, let's talk about a piece of engineering that is just wild. I mean, it seriously looks like it crawled straight out of a sci-fi movie, but it's very real, and it's built to solve some of the toughest, most head-scratching challenges in construction and maintenance you can imagine.
I mean, just think about it for a second. How on earth do you get a worker up to repair, say, a massive cathedral ceiling? Or what about cleaning the inside of a giant glass atrium on a skyscraper? Or get this, servicing a wind turbine that's sitting on the side of a really steep hill? Your standard, run-of-the-mill truck-mounted lift? Yeah, no way. It's just not going to happen.
Well, the answer is you use one of these. This is the spider lift. And honestly, it's a total masterclass in clever, versatile engineering. The whole design is basically borrowed from nature, and that's what gives it these almost unbelievable abilities to get into places. So let's really dig in and see what makes this thing tick.
Okay, so what's the official name? You know the technical term? It's a tracked aerial platform. But come on, everybody calls it a spider lift, and for a pretty obvious reason, right? The entire machine, its whole design philosophy, boils down to three key things: being crazy agile, having a really light touch on the ground, and maybe most importantly, the ability to plant itself and be stable just about anywhere.
So the big question is, how does it actually do all that? Well, it all comes down to three basic actions. And yeah, you guessed it, they're pretty much exactly what you'd expect from the spider it's named after. Let's break down the anatomy of this incredible machine.
All right, first things first. It's got to get to the job site, and a lot of the time, that means it needs to do one thing: crawl.
And these tracks, they give the machine this really cool dual personality. I mean, on the one hand, they are rugged. They can climb some seriously steep grades. We're talking up to 31% on some models. But then, on the other hand, they have this incredibly gentle side. They spread the weight out so much that they barely press on the ground. You can even get non-marking rubber tracks, so this thing can literally crawl across a priceless marble floor in a museum and not leave a single scuff. And here's the kicker. Some of them can actually suck in their own chassis hydraulically to get so narrow they can fit through a standard single doorway. How cool is that?
Okay, so it's crawled into the perfect spot. But it can't just start reaching for the sky. Nope. First, it has to get stable. It has to plant itself. And this is where that whole spider thing really clicks into place. It has these outriggers that are basically legs. They spread out to create this super wide, rock-solid base. The magic word here is variable asymmetrical jacking. It sounds complicated, but all it really means is that each leg can be set up totally independently from the others. So you can put this machine on a slope, on a set of stairs, whatever, and it can level itself out perfectly. It's just genius.
What that flexibility gives you is a machine with multiple footprints. So, if you're in a big open space, you can spread those legs out wide for maximum stability. But if you're wedged into a narrow alleyway or trying to set up between equipment on a factory floor, you can use a much tighter, narrower stance. It's all about adapting to the space you're in.
All right, so we've crawled into position, we've planted our feet, now it's time for the main event. It's time to reach.
And the arm, the boom, it's a whole other piece of engineering magic. It's not just one long pole. It's usually a mix of sections that knuckle or bend and other sections that telescope straight out. Then, right at the very end, you've often got this little extra articulating arm called a jib. That's what gives the operator that last little bit of fine-tuning to sneak the basket exactly where it needs to go. But you always have to remember the trade-off. You can't beat physics, right? The more weight you've got in that basket, the less you can reach out sideways. It's a balancing act.
Let's look at a real-world example, the Falcon FS330Z. It perfectly shows this trade-off. So with a light load, just one person and some tools, about 100 kilograms, you can reach out a whopping 19 meters. That's huge. But if you load that basket up to its max of 250 kilos, your reach comes down to 16 meters. And you don't have to guess. The machine's brain, its computer, is watching this constantly to make sure everything stays well within the safe zone.
Now, it's really important to know that spider lift isn't just one thing. It's a whole category, and the sheer variety of these machines is, well, it's staggering. They're all tailored for completely different kinds of jobs.
So at one end of the scale, you've got these super compact models, the ones that are really designed for working indoors. I mean, we are talking about machines that are just unbelievably skinny.
Check this one out, the Ruthman BlueLift SA11. It's only 0.78 meters wide. That is narrower than a lot of refrigerators. It means you can easily drive it down hallways, pop it into an elevator, and get through any normal doorway. It's the perfect tool for jobs like changing out lights way up in a shopping mall ceiling or, cleaning the glass in a big hotel atrium.
But then you go all the way to the other end of the spectrum, And there, you find the absolute titans, the giants, the ones built to reach heights that just seem impossible for a machine that can still get into tight spots.
54 meters. Yep, you heard that right. The biggest ones out there, like the platform basket 54T, can get a worker up to 54 meters in the air. Let's put that into perspective for a second. That's like standing on the roof of a 15-story building. And that is just an incredible achievement for a machine that isn't some massive crane.
And this chart, this really tells the whole story. It just lays out the massive range we're talking about. So on the left, you've got that compact little guy, the CMC S15, barely more than 3/4 of a meter wide, weighs less than 2 tons. Then you've got your popular mid-size model in the middle. But look all the way to the right, the heavy-duty platform basket 54T. The height is incredible, sure, but look at that weight, 23,000 kilograms. It just shows you there's a spider lift built for pretty much any scale of job you can throw at it.
So you might be wondering, what's behind all this? What makes this incredible performance possible? Well, it's all about the tech. These machines are just packed to the gills with cutting-edge stuff, and it's always evolving, always pushing the limits of where we can go.
For starters, look at power. We're seeing huge leaps forward here. You've got these awesome lithium-ion battery systems that are super quiet and have zero emissions, which is perfect for working inside. Or you can get bi-energy hybrids that have both a diesel engine for outdoor work and an electric motor for when you move inside. They're also getting way smarter. Some have remote diagnostics, so a technician can log in from miles away to see what's going on, or even push a software update. And the versatility? It's just off the charts. Some models let you take the basket off entirely and pop on a 1,000-kilo winch. So, it basically turns into a tiny, agile crane.
You know, there's this line from a Hinowa brochure that really just nails it. It says, "The innovations of the Performance ISE series make the aerial platforms extremely versatile and suitable for professionals of different sectors." And that's the key, right? The innovation isn't just about going higher or getting smaller. It's about making these tools smarter, safer, and useful for way more people in way more industries.
And that really leaves us with one final big thought. These amazing machines, they exist because someone had a problem that seemed impossible to solve. They needed to get somewhere they just couldn't reach. So as this technology keeps getting better and better, you have to ask yourself, what new challenges are we going to be able to solve? What new heights, and I mean that both literally and figuratively, is this kind of thinking going to help us reach next?